Hello. In today's video, we will be doing a quick experiment to demonstrate simple distillation. Distillation is a process to separate liquids from solutions where substances have different boiling points. In this demonstration, we will see how water can be separated from a salt solution by simple distillation, giving us pure distilled water. For this experiment, you'll need a flask of a salt solution and a beaker to collect the distilled water. You'll also need a glass tube from the flask, which will act as a condenser. We first made a salt solution by dissolving a teaspoon of common table salt in 100 milliliters of water. Once the salt had fully dissolved, we poured the solution into a flask. We closed the flask with a one-holed rubber stopper and attach a glass tube to the stopper. We then heated the flask with a bunsen burner until the solution comes to boil. As the boiling point of water is 100 degrees, and the boiling point of salt is much higher than that, the water will evaporate as water vapor, leaving the salt in the solution. The water vaporizes up the flask and goes into the tube. As it comes to contact with the colder surface of the tube, it will then condense into water droplets, which then flow down the tube into the beaker. After we've collected enough pure water in the beaker, we need to still test if it is indeed pure distilled water, or whether it still does contain salt. We can, of course, just taste the water in the beaker to see if it's salty, but this can be dangerous if the equipment we use is tainted with other harmful chemicals from previous experiments. Electric conductivity tests can differentiate between salty and distilled water. A much simpler method is to freeze a sample of the salty water and a sample of the distilled water. You can see here that the salt water is not frozen, while the distilled water has frozen into an ice cube. This is because salt water has a freezing point of below zero, about -5 degrees centigrade. The pure water, however, has frozen at 0 degrees Celsius, indicating the absence of salt in the solution. In the second part of the experiment, we demonstrate how we can distill pure isopropanol alcohol from a diluted solution of alcohol that has been mixed with water. We use the same setup as before, but instead of salt water in a flask, we mixed 5 milliliters of alcohol with water in a test tube and heated it as before. The boiling point of alcohol is 80 degrees Celsius, which is lower than that of water. We therefore heated the test tube to about 80 degrees, making sure that the temperature never reaches the boiling point of water at 100 degrees. The alcohol will then evaporate at its boiling point, the vapor rising up the test tube and through the glass tube and condensing as it touches the cold glass. The liquid ethanol will then drip into the second test tube where we can then collect it. Make sure the second test tube is closed with a stopper, as alcohol can also evaporate at room temperature. How then do we test the samples? Again, by freezing. Isopropanol alcohol freezes at minus 89 degrees Celsius, and the sample with the alcohol will not freeze at all if you put it in the freezer of your refrigerator. The water will of course freeze into an ice cube. Thank you for watching.